Hello and welcome to Mathmaster. The last class we have discussed about what is a set, what are the different kinds of sets, and how can we describe a set. Okay? In today's class we will discuss what is a subset and what are power sets. Let us start with subsets. Let A and B are two sets. Okay? Let A and B are two sets. Then A is said to be a subset of subset B if every element in A is an element of set B. Okay? And also, in this case, we say that A is contained in B. Okay? If there are two sets A and set B, and if every element of set A is also an element of set B, then we say that A is a subset of B, or we also say that A is contained in B, and we denote it as A is a subset of B. This symbol represents subset. Okay? So, if that happens, then we also say that B is a superset of set A. Okay, if A is a subset of set B, then B is a superset of set A. Okay, let us take an example. Let A be a set where X such that X is a person living in Odisha. Okay, and B be a set where X such that X is a person living in India. Okay, so as we know, Odisha is a state of India. That means Odisha comes under the territory of India. So, if a person is in Odisha, it directly implies that he lives in India. That means if I pick any person who lives in Odisha, he will also be living in India. That means if I pick any element in the set A, then that element will also be an element of set B. So in this case, say that A is a subset of set B. Okay. Now another example. Let A be a set where the elements are 1, 2 and 3. Okay. And B be a set where the elements are 1, 2, 3 and 5. Okay. So here, if you pick any element, let's say 1, 2 or 3, then we can find it in set B also. That means every element of set A is found in set B. Okay. So we say that A is contained in C. Okay. But here B has an extra element, that is 5, that is not present in set A. So we call B as the superset of the set A, because in a superset there must be an element X belongs to B such that X does not belong to A. Okay, there must be one extra element in the superset that is not in the set. Okay, so this is the concept of subsets and supersets. Now comes the concept of proper subset and proper subset. Okay, we learned that if every element of A is an element of set B, then we say that A is a subset of set B. Okay, but what if every element of set B is also an element of set A? Then in that case, A will be equal to set B. Let us take an example. A is a set of 1, 2, 3. C is a set where elements are 1, 2 and 3. In this case, any element you pick from set A, you will find it in set B, and also any element you take from set B, you will find it in set A. So, in this case we say that A equal to B. Okay. Now, what do you mean by proper subset? Let A be a subset of set B. Okay. Let set A be a subset of set B, and A is not equal to B. Okay, if these two conditions holds, then we say that A is a proper subset of set B. Okay, and in this case we denote it as A is a proper subset of B. Here we don't put any extra line below this symbol. Okay, this means this is a proper subset. Okay, then improper subset. In case of improper subset, A is a subset of B for A is also equal to B. Okay, in this case A is a subset of B and also A is equal to B. So we say that A is improper subset of B. Now let A be a set where the elements are 3, 6 and 9. Okay, where the elements are 3, 6 and 9. So if I pick any element from the set A, let's say 3. Okay, then it will be also in set A because we are picking the element from the set A only. Hence, we can say that A is a subset of set A. If we take any set, then it is a subset of itself, or we can say that it is an improper subset of itself because every element of a set belongs to itself. Now we will discuss some important properties of a subset. Okay, the first property is that every set is a subset of itself. We have discussed it earlier. Okay, so every set is a subset of itself. The next one is the empty set is subset of every set. Let A be an empty set. Okay, empty set means A does not have any element. So if I take any set B, okay, any set, let's say 2, 4, 6, 8, all these are 8 elements. Okay, as A does not have any element, then we can say that any element in A is also an element of C because A does not have any element. Hence, the empty set is a subset of every set. Now, the third property, it says that the number of subsets of finite set of n elements is 2 to the power n. Okay, if I have a set A which has n number of elements, then there are total 2 to the power n number of subsets it has. Okay, so let us verify by taking an example. Okay, let C be a set where the elements are 1, 2 and 3. Then what are its subsets? The subsets are 5, 1, 2, 3. So these are the possible subsets of set C. Okay, these are the possible subsets of set C. Here, if we count these, then there are 8 number of subsets of set C. So now if I put the value here 2 to the power 3, then because C has total 3 elements, then 2 to the power 3 equal to 8. Okay, so this is verified that every set containing n number of elements is having 2 to the power n number of subsets. Okay. Now, based on the previous property, let us solve this question. Okay. Here it is given that there are two finite sets having the first set has m elements and the second set has n elements. Okay. And the number of subsets of first set is 56 more than that of the other. Okay. We need to find out the values of m and n. Okay. Now, we know that if a set has m elements, then it will have 2 to the power m number of subsets. Okay, and the first set has 2 to the power m subsets, and the second set has 2 to the power m subsets. And it is also given that the difference between the number of subsets of both the set is 56. Okay, now if I take to the power n as common, then it will be to the power n whole into to the power m minus n minus 1 equal to 56. Now I can write 56 as 2 to the power 3 whole into 2 to the power 3 minus 1. I can write 56 like this. Okay. Now compare this expression with this expression. By comparing these two, you can write your n equal to 2 to the power 3 and 2 to the power m minus n minus 1 equal to 2 to the power 3 minus 1. Okay. This implies n equal to 3 and 2 to the power m minus n equal to 2 to the power 3. This will imply m minus n equal to 3. But here we found out that n equal to 3. So putting the value of n here, we will get m minus 3 is equal to 3. This will imply m equal to 6. Okay. This way we can find out the value of m and n. That is m equal to 6 and n equal to 3. So we can solve this kind of problems using the property. Now, what is a power set? Okay. Let A be a set, then the collection of all the subset of A is called the power set of A. Okay. We have studied about subset. Okay. Let A be a set where the elements are 2, 4 and 6. Okay. Then its subsets are as follows. Okay. These are the subsets of the set A, or you can say that this is a collection of the subsets of set A, and this collection is known as power set of set A, and we can write it in roster form like this. Okay. So one important thing is that the element of a power set is always set. Okay. We cannot write 2 belongs to power set of A. We have to write the set, the singleton set which has the element 2 is an element of power set of A. Okay, we can write 2 is an element of A, but we cannot write this one. Okay, because the elements of power set of A are always the subsets of A. So, we have learned that there are 2 to the power n number of subsets. So, we have learned that there are 2 to the power n number of subsets of a set which has n number of elements. Okay. Now, we learn that the power set of A is the collection of all the subsets of A. So, we can say that there are 2 to the power n number of elements in power set of A. Okay, or you can write as number of elements in power set of A is 2 to the power n if number of elements in A is n. Okay. Thanks for watching. Like and share it, and also to get the latest update of videos, subscribe it. Thank you.